Welcome all of you. Rayat Shikshan Samstha Satara Rose Project 2021-22 for 11th Science conducted by Yashwantrao Chavan Institute of Science Satara. In the last lecture, we have seen properties of determinant and examples on properties of determinant. In this lecture, we will see the remaining part of determinant, that is applications of determinant. So there are various applications of determinant for 11th standard and 12th standard in different topics, even in physics. So there is one application which you have seen in 10th standard, that is Cramer's rule, how to solve simultaneous linear equations in two variables by using Cramer's rule. So in that method we have used 2 by 2 determinant. Now we solve the simultaneous equations in three variables, three linear equations in three variables. So applications of determinant, there is Cramer's rule, consistency of three equations in two variables, and some examples. So let us start. Application of determinant, that is Cramer's rule. Consider the following three linear equations in three variables x, y, z. So a1x plus b1y plus c1z is equal to d1. Second one is a2x plus b2y plus c2z is equal to d2. a3x plus b3y plus c3z is equal to d3. Okay, so these are three linear equations in three unknowns. So these are three linear equations in three unknowns. Here ai, bi, ci, that is a1, a2, a3, b1, b2, b3, c1, c2, c3, and d1, d2, d3 are the constants, any real numbers. The solution of this system of equations is x is equal to dx upon d, y is equal to dy upon d, and z is equal to dz upon d, provided d not equal to 0. So here, what are d, dx, dy, and dz? So d is, it is a coefficient matrix, that is coefficient of x, y, z. So sorry, this is the determinant of coefficient. You can see, so these are the coefficients of x, y, z here, d. Now dx is determinant obtained by replacing coefficient of x by constant, that is d1, d2, d3. Now dy is determinant obtained by replacing the coefficient of y by constant, so that is in red color, d1, d2, d3. And dz is replacing the coefficient of z by constant. So these are the dx, dy, dz, and d. So d must be different from 0. So let us see example. Solve following linear equations by using Cramer's rule. So these are three equations: x plus y plus z is equal to 6, x minus y plus z is equal to 2, and x plus 2y minus z is equal to 2. So there are three linear equations in three unknowns. Okay. So here, solution. Given equations are x plus y plus z is equal to 6, x minus y plus z is equal to 2, and x plus 2y minus z is equal to 2. Now we first find the value of d, that is coefficient determinant. D, that is coefficient of x, y, z, 1, 1, 1, 1 minus 1, 1, 2 minus 1. So we expand this determinant by first row, our usual expansion. So that is 1 minus 2 minus 1 minus 1 minus 1 plus 1 into 2 plus 1. So बघा प्रत्येक वेळेस हे डिटर्मिनंटचे एक्सपान्शन सांगण्याची गरज नाहीये. आता तुम्ही त्याशी फॅमिलियर झालेला आहात, हाऊ टू एक्सपांड द डिटर्मिनंट. सो दिस इज -1 plus 2 plus 3. So d is 4. Now for solving these simultaneous equations by Cramer's rule, we have to solve 4 determinant. त्यापैकी आपण d आता सोडवलेला आहे. आता dx आता बघा dx there is, so we have replaced the coefficient of x by constant, that is 6, 2 and 2. So here now expand determinant dx. So 6, 1 minus 2 minus 1 minus 2 minus 2 plus 1. So 4 plus 2. So that is 6 minus 1 minus 1 minus 4 into 6. So minus 6 plus 4 plus 6, that is 4. So dx is 4. Now we find dy, replacing the coefficient of y by constant, determinant obtained by replacing coefficient of y by constant. So here in d we have replaced the coefficient of y by constant. Now expand this determinant dy. So 1 minus 2 minus 2, middle sign has minus sign. So that is here minus 6 minus 1 minus 1 plus 1, 2 minus 2. So its value comes to be dy is equal to 8. dz. Now replacing the coefficient of z by constant and expanding. So 1 minus 2 minus 4 minus 1, 2 minus 2 plus 6, 2 plus 1. So this is minus 6, this is 0 and 6 into 3. So minus 6 plus 0 plus 18, that is 12. So we have all the four values d, dx, dy, dz. Now by using Cramer's rule, x is equal to dx upon dy is equal to dy upon d, z is equal to dz upon d. Now putting the values, so dx is 4, d is also 4, 4 upon 4, y 8 upon 4, z 12 upon 4. So x is equal to 1, y is equal to 2, z is equal to 3. So whether solution is correct or not, we can check by substituting these values in given equations. So if we substitute all these values in this equation, 1 plus 2 plus 3, that is, here it is 6, here 1 minus 2 minus 1 plus 3, that is 2, here 1 plus 2 minus 3, 1 plus 4, 5 minus 3, that is 2. So given value satisfies the given equation, so our solution is correct. Now we go for second example. बघा आणखीन एक same example आहे, same types. So these are three linear equations in three unknowns. Again we have to find d, dx, dy, dz. So given equations are x plus y minus 2z is equal to minus 10, 2x plus y minus 3z is equal to minus 19, 4x plus 6y plus z is equal to 2. So now d, coefficient of x, y, z. So its expansion is like this, 19 minus 14 minus 16. So this is minus 11. So d is minus 11. Now dx replacing the coefficient of this coefficient of x by constant, that is minus 10 minus 99, that is 2. So here again expansion of determinant dx. So we have 19 into minus 10 minus 13 into minus 1 and minus 116 into minus 2. So this value is 55. Now dy. So expansion of this determinant is again minus 19 plus 6, minus of minus plus 10, 2 plus 12, minus 2, 4 plus 76. So this value is minus 33. Now dz. Again dz is obtained by replacing the coefficient of z by constant. So expansion of this determinant again. So this is the expansion. तुम्हाला माहित आहे की डिटरमिनंट कसा एक्सपांड केला जातो, त्यामुळे प्रत्येक वेळेस हे काय कॅल्क्युलेशन आहे सांगण्याची गरज नाहीये. सो मायनस 44. बघा जनरली असं असतं, जर आपण धरून चालू आहे की इंटिजर सोल्युशन असतं गिवन इक्वेशन्सना, तर dx dy dz हे d च्या पटीत असतात. सो dx dy dz मस्ट बी द मल्टिपल्स ऑफ d. सो बघा d न dx ला डिवाइड होण्यासाठी dx हा d च्या पटीत असायला पाहिजे. सो x इक्वल टू 55 अपॉन मायनस 11, y इक्वल टू मायनस 33 अपॉन मायनस 11, z इज इक्वल टू मायनस 44 अपॉन मायनस 11. So x equal to minus 5, y is equal to 3, z is equal to 4. So these values satisfies all these three equations. So therefore it is a solution. Now we see one wording example here. The sum of three numbers is 15. If the second number is subtracted from the sum of first and third numbers, then we get 5. When the third number is subtracted from the sum of twice the first number and the second number, we get 4. Find three numbers. So we have to find three numbers which satisfy all these three conditions. So let us start solution. So we have to consider those three numbers. So let the three numbers are A, B, C. आपण ते A, B, C तीन नंबर कोणते आहेत ते मानलेले. आता त्याच्यावर इक्वेशन तयार करणार आपण, लिनियर इक्वेशन. तर पहिली कंडिशनच आहे इथं बघा, the sum of three numbers is 50. So here A plus B plus C, from the condition given in the example, A plus B plus C must be 15. Now second condition, if the second number is subtracted from the sum of first and third number, the number then we get is 5. बघा second number पहिल्या आणि तिसऱ्या नंबरच्या बेरजेतून सबट्रॅक्ट करायचा आहे आणि आपल्याला 5 मिळतो. So here we have the second equation, A plus C minus B. Second number is subtracted from the sum of first and third number, we get 5. So here A minus B plus C is 5. When the third number is subtracted from the sum of twice the first number and second number, we get 4. So this is 2A plus B. When the third number is subtracted, so minus C from the sum of what? Twice the first number and second number. 2A plus B madun has third number subtract केला की 4 मिळतो. So we have 2A plus B minus is equal to 4. So now we have all these three equations. So let me draw this. So these are the three equations. Okay. Now we have to find the solution by using Cramer's rule. So that is, we will find d dx dy dz. So you know how to expand the determinant of order 3 by 3. So this is the expansion. हे बघा या प्रकारे असं एक्सपान्शन होणार आणि d ची व्हॅल्यू 6, dA 15 1 1 5 minus 1 1 4 1 minus 1. So value of dA is 15 1 minus 1 minus 1 5 minus 4 1 into 5 plus 4. So this is 15 into 0 minus 1 into minus 9 1 into 9. So 9 plus 9 18. So this value is 18. Now dB. So here we have dB replacing the coefficient of B by constant. आणि हे असं एक्सपांड केल्यानंतर आपल्याला व्हॅल्यू मिळते 30. ठीक आहे. So we have calculated the value of D, dA and dB. Now it remains to find value of C, that is DC. So here it must be DC. So expansion of DC. So by using this expansion, we get value of DC is 42. So by Cramer's rule, A is equal to dA upon D, Y is equal to dB upon D, and Z is equal to DC upon D. Instead of, here we have taken the variables are A, B, C. So here must be B, here must be it is C. So now, so A 18 upon 6, B 30 upon 6, C 42 upon 6. So X equal to 3, Y is equal to 5, Z is equal to 7. So actually it must be A is equal to 3, B is equal to 5, C is equal to 7. So these are three numbers which satisfies all the condition given in the example. Their sum is 15 and all that. Okay. So next example. So answer, the required three numbers are 3, 5, 7. Now we see the consistency of three equations in two variables. consistency of three equations in two variables. Consider the system of three linear equations in two variables x and y. A1x plus b1y plus c1 is equal to 0. So these are the three linear equations in two unknowns. These three equations are said to be consistent if they have a common solution. दिलेले इक्वेशन कंसिस्टंट आहेत असं कधी म्हणायचं जर त्यांना कॉमन सोल्युशन असेल, तिन्ही इक्वेशन सॅटिस्फाय करणारा एकच सोल्युशन असेल तर त्यांना काय म्हणायचं कंसिस्टंट. सो नाउ वी फाइंड हाउ टू examine the given equations are consistent. The necessary condition for the equations a1x plus b1y plus c1 is equal to 0, a2x plus b2y plus c2 is equal to 0, and a3x plus b3y plus c3 is equal to 0 to be consistent is determinant of a1 b1, determinant of their coefficient is 0. So this is the necessary condition. If these equations are consistent, if they have the common solution, then its determinant must be equal to 0. This is a necessary condition that the equations are consistent. The above condition of consistency is in general not sufficient. So there are some equations whose determinant is 0, but they don't have a common solution. So equations are not consistent. So this is necessary condition. Once the three equations are have common solution consistent, so their determinant must be equal to 0. But other way around is not true. So theorem, the necessary condition for the equations, these three equations in two unknowns to be consistent is, so this determinant must be equal to 0. बघा ही कंडिशन कशी आलेली आहे, कशी तयार झाली त्याचं प्रूफ बघणार आहे आपण. Proof, we shall now obtain the necessary condition for the system 1 to be consistent. This system 1 is consistent. Consider the system of three linear equations in two variables x and y. So here consider the system of three linear equations in two variables of which we have taken only two. हे बघा असे शेवटच्या दोन इक्वेशन मी इथे घेतलेले आहेत. आता कन्सिस्टन्सी म्हणजे काय, तिन्ही इक्वेशनला कॉमन सोल्युशन पाहिजे. म्हणजे मी काय करणार, हे दोन्ही इक्वेशन सॉल्व्ह करणार आणि दोन्ही इक्वेशन सॉल्व्ह करून एक्स वाय च्या व्हॅल्यू करणार. आलेल्या एक्स वाय च्या व्हॅल्यू जर फर्स्ट इक्वेशन सॅटिस्फाय केलं तर तिन्ही ऑल दिस थ्री इक्वेशन्स हॅव कॉमन सोल्युशन. ठीक आहे. सो नाउ वी सॉल्व्ह अबाउट these two equations. So x is equal to, by Cramer's rule, replacing the coefficient by constant, and y again replacing dx upon d, dy upon d. Now put these values in equation a1x plus b1y plus c1 is equal to 0. हे बघा आपण हे दोन इक्वेशन सोडून हे सोल्युशन काढलं. आता हे सोल्युशन तिसऱ्या इक्वेशन ने सॅटिस्फाय करायला पाहिजे कारण कॉमन सोल्युशन साठी. तर बघा x च्या जागी हे x ची व्हॅल्यू ठेवलेली आहे, y च्या जागी ही y ची व्हॅल्यू ठेवलेली आहे आणि c1. सो नाउ टेक द एलसीएम ऑफ थ्री टर्म्स. म्हणजे या c1 ला डिवाइड मल्टिप्लाइड बाय a2 b2 a3 b3 2 by 2 डिटर्मिनंट मल्टिप्लाय करणार. डिटर्मिनंट छेद समान झाल्यामुळे तो इकडं RHS ला मल्टिप्लाय होऊन कॅन्सल होईल. आता बघा आपल्याला हे असं मिळालेलं आहे. यामध्ये बघा -a1 C2 C3 B2 B3 याचा अर्थ काय, तर बघा या फर्स्ट कॉलम मधून मी मायनस साइन बाहेर घेतलं. हिअर इट इज मायनस साइन, हे मायनस साइन बाहेर घेतलं. पुन्हा इथून सुद्धा ह्या डिटर्मिनंट मधून सुद्धा हे मायनस साइन बाहेर घेतल्यामुळे इथं म्हणजे -1 बाहेर घेतल्यामुळे इथं मायनस साइन आले. ठीक आहे. सो other part is same. Now आता बघा इथं काय केलेलं आहे. सो वी हॅव इंटरचेंज फर्स्ट कॉलम अँड सेकंड कॉलम. फर्स्ट कॉलम अँड सेकंड कॉलम इंटरचेंज केल्यामुळे डिटर्मिनंटची व्हॅल्यू चिन्हामध्ये बदलते, मायनस साइन येणार आणि मायनस मायनस बिकम्स प्लस. पुन्हा -b1 a2 a3 c2 c3 plus C1, A2, A3, B2, B3. Now this is what? And here je काय आहे? So this is the expansion of determinant A1, B1, C1, A2, B2, C2 and A3, B3, C3 which is equal to 0. हेच काय? तर हेच expansion आहे by first row. ठीक आहे? So this is the necessary condition that the equations to be consistent. Now we see some examples on consistency. Examine the consistency of the following equations. So here 2x minus y plus 3 is equal to 0, 3x plus y minus 2 is equal to 0, 11x plus 2y minus 3 is equal to 0. इथं एक ध्यानात ठेवायचा आहे, जो कॉन्स्टंट टर्म आहे एक तर पूर्णपणे LHS ला पाहिजे किंवा पूर्णपणे RHS ला पाहिजे. तिन्ही इक्वेशनच्या कॉन्स्टंट टर्म लेफ्ट हँड साइडला पाहिजेत किंवा राइट हँड साइडला पाहिजे. So solution. So we are given equations. Now we have consider if this determinant 0, then we can say that the equations are consistent. So this is now 2 minus 1 3 coefficient, 3 1 minus 2 and 11 2 minus 3. And if we expand this determinant, you will get the value that is 15 minus 15 0. So given equations are consistent. बघा आपण त्याचा कोएफिशिएंटचा डिटरमिनंट सॉल्व केला, तो एक्सपांड केला, तो व्हॅल्यू 0 आली. Therefore they have the common solution. So given equations are consistent. ठीक आहे. A1 B1 C1 A2 B2 C2 A3 B3 C3 मध्ये हे रिप्लेस करून एक्सपांड करून व्हॅल्यू 0 आलेले. Question 1. Again, examine the consistency of the following equations. Another example. So here, given equations can be written in standard form as standard form मध्ये लिहिलेला आहे. कारण इथं बघा सेकंड इक्वेशनचा जो कॉन्स्टंट आहे तो उजव्या साइडला, तो आपल्याला डाव्या साइडला लिहायला पाहिजे किंवा एका साइडलाच पाहिजे. हा -4 इकडे +4 आहे ना, हा ठीक आहे, हा -4, हा -3 आणि हा झाला +5 एका साइडला. इथं मला थोडस चेंज करू दे. दिस मस्ट बी -3 इज इक्वल टू 0. ओके. So replacing the A1 B1 C1 A2 B2 C2 and A3 B3 C3 by the numbers आणि हे एक्सपांड केलेले अशा प्रकारे डिटरमिनंट. तुम्हाला माहित आहे आपण प्रत्येक एक्झाम्पल मध्ये डिटरमिनंट एक्सपांड करतोय. तर हे 22 into 2 4 minus 42 48. This is 50 which is not equal to 0. So this determinant value, it is different from 0. So the equations are not consistent, inconsistent, they don't have a common solution. So given equations are not consistent. So now another example. Find K if the following equations are consistent. आता आपल्याला माहिती दिलेली आहे की तिन्ही इक्वेशन्स कन्सिस्टंट आहेत, तर K ची किंमत काय? Similar way. So here K is there, unknown. So given equations are, so these are the given equations. We are given that equations are consistent. So that's why we can take this value of determinant is 0. So this must be equal to 0 because we are given the equations are consistent. So therefore now expand this determinant. So 12 plus 12 minus 2k minus 3 here 6k minus of minus k minus 4 minus 4 minus 4. So 10k into 2 20k here 7k minus 3 minus 4 minus 8. So 20k minus 21 plus 32. So that is minus k is equal to 32. So here k is equal to 32. If we replace this k by 32, then all these three equations have common solution or they are consistent. So this is the solution. Okay. Thank you all of you. We shall stop here.